Welcome back, ladies and gentlemen, section 10.4 here. Now that we've worked with simplifying radicals, now it's time for us to solve some radical equations. Now, in my opinion, this is a little bit easier, but again, that's just my opinion. So you guys will be the judge of what's easier and what's harder. So let's dig into it, and we'll try and make this one a quick one. What we're hoping to do is use the idea of squaring both sides of the equation to get rid of the equal sign. The goal is still to get x by itself, but we want to square both sides. So if we have something like the square root of x equals 4, then what we would do is we'd square both sides in order to get rid of that radical sign, because the square of a square root is just whatever number's underneath of it. So the square root of x squared is just x. Similarly, we might have something like this. We have the square root of x plus 4 equals 8, which actually we'll find is the same thing. But again, the idea here is, we're going to have this square root sign plus some other stuff, and we're going to still have to get x by itself. So that'll have some tricks involved. And then finally, we'll get these big monsters, which we'll deal with, and they're going to make up the brunt and the most difficult thing that we're going to have to do today. So that's what we're looking for. Let's get into how it actually happens. First, we'll take our simple case where we have something like the square root of a equals 6. Well, what I'm going to do is I'm going to square both sides. So the square root of a squared equals 6 squared. When I square the left side, that gets rid of the radical sign, and what I'm left with is a equals 6 squared, 36. And that's it. That's the nuts and bolts of what we're doing, but again, this one's going to get trickier pretty quick. But at its simplest form, that's what we have. Some variable, square root of it, square both sides to get rid of the radical sign. Whatever comes out on the other side is what comes out. I'll pause if you need more time. Next, we've got problems where the radical is not by itself, and so before we can do what we want to do to isolate the variable, we have to isolate the radical. So let's look at an example like the square root of p plus 3 equals 8. Well, we'd like to just square both sides, but if I square both sides right now, if I want to do it properly, I'm going to have to get into some foiling, and we're going to save that until we absolutely have to do that. So instead, what I'll do is I'll subtract 3 from both sides, which will then get rid of this 3. 8 minus 3 is 5, and now I just have the square root of p equals 5. This looks just like our last problem. We can square both sides, get rid of that radical sign, and end up with p equals 25. So the purpose of this example is to show this idea that if I have something outside of the parentheses, I have to get rid of that first, and then I can square both sides. Now, I want you to think for a moment. You can pause to think about this idea. If, let's say I had a 2 up here, okay, so now it's 2 times the square root of p. How would I get rid of that 2? Hopefully you thought to yourself or said out loud, divide. Okay, we would divide by 2 just like we normally do. Okay, we treat that everything inside those square root signs just like we would if they were in parentheses. We have to get rid of them by using the opposite operation. So just have that in your head. I don't think there's any examples like that, but keep it in the back of your mind. All right, with those two ideas in mind, go ahead and try this one out. I'll pause. Okay, looking at my work, you can see what I did. First thing I did, subtract 5 from both sides. That brings us down to the square root of g minus 2 equals 10. Then I square both sides of the equation, okay? And once I do that, the square root sign goes away here. 10 squared becomes 100. And now I have the g minus 2, add g to both sides, and I have g equals 102. And again, if at any point in time you need to pause, do so. All right, this is the rough stuff, and I call this the rough stuff because this is when it gets difficult. Okay, this is when we have to really start pulling back from chapter 8, which I know you guys just loved, and we're going to have to do a little bit of factoring. And before we even do the factoring, we have to do some foiling, because we have to think about what it means to square a binomial, right? Remember, binomial has 2 terms, so I'm taking the square root of binomial, which isn't a big deal. But when I square both sides, I'm squaring a binomial. Now, the common mistake was to think that the quantity k minus 1 squared was k squared minus 1 squared. But remember, it's not that. We have to FOIL. So when we square both sides, what we actually end up with by FOILing is k plus 1, radical sign goes away, equals k squared minus 2k plus 1. And if you need to, take a moment on your own and do the foiling, k minus 1 times k minus 1, to see where I got that k squared minus 2k plus 1. And if you practiced the special products at all, you'll remember that this is actually a pattern that's always going to hold true, but we didn't stress that, and I did that intentionally if you'll remember. So do your foiling, and then we'll move forward. Okay, thank you for checking my work. Now, you'll notice I have the k squared term, which means I now have a quadratic. Anytime I see a quadratic in my equation, excuse me, anytime I see a second power in my equation, I know I have a quadratic. So that means I'm going to have to do some of that chapter 8 stuff, or maybe even some chapter 9 stuff in order to solve this equation. But if you remember from chapter 9, when we were really working with solving these quadratic equations, the first thing I have to do is set the left side equal to 0. So what I'll do is I'll subtract the k and the 1 from both sides. Okay, minus k minus 1 minus k minus 1. That will turn the left into 0, and it will leave me with k squared minus 3k on the right, 0 on the left. Take a moment to catch up, and if you have questions, jot them down so that we can talk about them in class. Now, here comes the factoring part. Now, luckily, this one's fairly straightforward as far as factoring goes, in the sense that all I need to do is a greatest common factor, factoring. So I look at the greatest common factor between k squared and 3k, or negative 3k, and I end up finding out that is k. So I pull out the k up front, leaving with k minus 3 on the inside. Okay. If you need extra practice factoring, which you all do, see me and we can arrange something. But this is our basic greatest common factor factor problem. You will see some in the homework and on the quiz that require you to do a full trinomial. Strongly recommend you retrieve your section 8.5, 8.6, check that 8.7 notes, get all that stuff back together so that you can do the factoring, because quadratic formula will work too, but I think the factoring is a little easier, a little quicker. But if you didn't like factoring, then quadratic formula, your section 9.5 notes, will also get you what you need. Now, let's assume that you are factoring, you didn't use the quadratic formula. Then you'll remember that this is not our solution, right? I'm looking for the number that I can plug in for k that's going to make this true number or numbers. And we remember with our factoring problems, with our quadratic equation problems, we were expecting to get two answers. So let's figure out what those are. If we have this down as our work simplified, we need to then actually use the zero product property to get that k equals 0, which would be our first factor set equal to 0, or k minus 3 equals 0, the second factor equal to 0. Set each of those equal to the variable, or get the variable by themselves. This one's already done. Add 3 to both sides here, and we get k equals 0 or k equals 3. Okay, zero product property. Good time to pause. Make sure if you have questions that they're getting answered, because again, this is something that a lot of us have to work hard at. Now, speaking of hard work, we are not done. And I know that may sound like bad news because we've already kind of been at this problem for a while, but we have one more thing we have to take into account. Okay, one of these two answers is not actually an answer. Let's look at what I'm talking about. If I take my first one, k equals 0, and I plug in 0 for k, all right, so I have the original equation here. I replace all the k's with 0. Well, once I simplify this, what I end up with is the square root of 1 equals negative 1. But it doesn't, okay? The square root of 1 is 1, not negative 1. And so, therefore, one of the quote-unquote solutions that I found with my factoring doesn't work. And the same thing would happen if I use the quadratic formula. One of my solutions doesn't work. Now, that of course then means I should probably check the other one to make sure any of them work. And if I plug in 3 for k, the square root of 3 plus 1 is the square root of 4. 3 minus 1 is 2. And it turns out, yeah, okay, the square root of 4, 2, does equal 2. So that's all good. So it seems as if that only one of my answers is going to work. And that's going to be the case for a lot of these problems that involve factoring. In fact, I think it's going to be the case for all of them. because of some reasons that I'm not going to get into, but they can be graphed. If you think about the sideways parabola we talked about, that's the reason why. Don't worry about that. The point is, if you are getting two solutions, you have to check your work. Let me say that again. You have to check your work, Mr. Young. You've been saying that all year, and I haven't checked my work once, and I'm still doing okay. This is the time when, if you do not check your work, you will get it wrong. This is not me expressing a lack of faith in your ability. It's saying that you have to check your work in order to verify if it's this as the extraneous solution or this as the extraneous solution. And there's no real pattern, no easy one to pick up. It's not about one's negative and one's positive, because you can see this one's 0, this one's 3. It's not about one being bigger or greater than the other. It's about the problem itself, and you have to plug it in to see which one is going to work. Okay, so please, 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 no, I'm not asking, I'm telling you, check your work. If you do not check your work, you will not get full credit for these problems, because you're going to end up with both solutions, and you have to be able to tell me which one is the correct one. Now, good news, that is all we're doing. It's not a little bit, but like I said, I think this chapter is easier because what we're doing is we're squaring both sides of the equation. The only problem comes when the right side of the equation, as we can see here, has some other tricks up its sleeve, okay? But ultimately, you square the left side, you square the right side in order to get rid of the radical sign, and you should be good. Remember to isolate the variable, or excuse me, remember to isolate the radical sign first, and then remember to FOIL if you're squaring a binomial. Do those two things, you should be okay. All right. If you don't remember how to factor, use the quadratic formula. Use whichever method is the most comfortable for you. You could graph them if you wanted to. You could plug them in your calculator after you set them equal to 0 and find the points where they intersect the x-axis. I don't care how you solve the quadratic. What I care about at this point is that you solve the quadratic correctly and then check your answers to figure out which of the two answers is an extraneous solution. Okay? Write down questions. See you guys in class next time.